Welcome to the Retail Tech Podcast. This is Darius Wasafi, your host, and today I am speaking with Peter Voss, the founder and CEO of Aigo.ai, a company that is pushing the envelope towards AGI. If you haven't heard about AGI, it stands for Artificial General Intelligence. Peter was actually one of the people that came up with this term in early 2000s. So I am really excited to talk with him and learn more about what AGI is and what his work is. So welcome to the show, Peter.
Yes, thank you.
Let's start with how you got to AGI, and then we'll work it through to the current times.
Yes, certainly. Well, I started out as an electronics engineer, had my own electronics company, and then I fell in love with software, and my company very quickly turned into a software company, and we actually did quite well. I developed an ERP software package for small to medium-sized businesses. Company grew to 400 people. We did an IPO, so that was all super exciting. But it's when I exited the company that it occurred to me that I was very proud of the software that we developed, but it was dumb, basically. If the programmer didn't think of something, it would just crash or give you an error message or something. So, the big challenge was is how can we build software that can think and learn and reason like humans, that has common sense, that can, learn on an ongoing basis and so on. So I embarked on a 5-year journey to deeply understand what intelligence is about, especially what's so special about human intelligence. So I studied epistemology, philosophy, the theory of knowledge, consciousness, free will, all of these important aspects of intelligence and how the mind works. I also studied cognitive psychology, how children learn, what IQ tests measure, how our intelligence differs from animals. And then, of course, I studied what had already been done in the field of AI. What I found in the field of AI is that the original dream, the term AI was actually coined 70 years ago. And they thought originally that they could get to human level intelligence within a few years. Of course, it turned out to be much, much, much harder. So what happened in the field of AI is it really turned into the field of narrow AI. And that's a very, very important distinction, because what narrow AI, and that's really what everybody's been doing for the last 70 years or 65 years maybe, is that you pick one particular area, one particular problem or set of problems that require human level intelligence. And then you use human intelligence to build a program to solve that problem. So a perfect example there is IBM's Deep Blue World Chess Champion. It's really the human ingenuity, the human intelligence to figure out how to write a program to play chess that AI is, rather than building an intelligent system that can learn by itself to play chess like we as humans would. And that same system could potentially learn, to how to program or how to do accounting or how to do medical research or whatever. So in 2000, I got together with a few other people who had similar ideas that we really wanted to go back to the original dream of AI, to build thinking machines. And so we decided to write a book on our different approaches to how we believe we could get there, the theoretical background and so on. And three of us actually sat down to come up with a title for the book, and we decided on artificial general intelligence, AGI, to really distinguish ourselves from what everybody else was doing, which was narrow AI. And really, to this day, it's still very much narrow AI. Even large language models are, in a way, a narrow AI, and we can talk about that. And that's really my passion and the journey I've been on for the last 25 plus years, to do research, to build prototypes, to commercialize, and to actually get to the goal.
Right. What does IGO do?
IGO was formed about 9 years ago. I had previous AI companies, but basically I relaunched our development with IGO about 9 years ago, and for a number of years we did pure development, not so much research, because we'd already done the research in prior years and prior companies. So it is to develop and to increase the IQ of our core technology to do that. Now, because AGI wasn't really a big thing 5 years ago, it wasn't on their radar. It was really hard for us to raise additional funds. So about 5 years ago, we decided to take our technology and to commercialize it in the call center. So our company turned from a development company into a commercial company, and we're quite successful in that. One of our big, well-known customers is 1-800-Flowers, Harry and David group of companies. However, middle of last year, we really came to the realization that there's so much talk about AGI. People are really starting to appreciate the value of AGI, that for us to be focusing on a narrow commercial domain and taking up all of our energy and so on didn't really make sense, to pursue maybe $100 million opportunity when really the whole reason for our company was to build AGI, which is a multi-trillion-dollar opportunity. So we decided to actually put our commercial business completely on hold middle of last year to 100% concentrate on cranking up the IQ of our system to get it all the way to full human level intelligence and AGI. If you have a lot of data like large companies have, you can, in fact, train a neural network, painfully to kind of do that with all the guardrails and things. And it involves quite a bit of human labor on an ongoing basis, to do that. For us, the big prize, and it's not really just financial. I absolutely believe that AGI will substantially improve human flourishing, that it will, help us flourish in so many different ways. And we can.
Let's go a little bit more in technical side of the difference between AGI and generative AI.
I'll explain it in a number of different ways. One of the ways to categorize it, which we found quite useful, is that, DARPA a few years ago came up with a presentation where they talk about the three waves of AI. And the first wave is basically good old-fashioned AI, which was, 80s, 90s, and this would be expert systems, and, Deep Blue World Chess Champion would be an example of that. That's the first wave. Now, the problem with those systems is they tended to be quite brittle, and, they really didn't have common sense in any way. Really just, the brittleness of these logic systems is really a huge limitation. Now, the second wave, of course, hit us like a tsunami about now 15 years ago or so, when people figured out how to use massive amounts of data, massive amounts of compute to build useful neural networks. And initially it was about speech recognition, translation, image recognition, and so on with deep learning approaches. But these are statistical big data approaches. And generative AI is sort of the tail end of that, with, the transformer technology having been introduced that sort of, made this approach even more powerful. And we have these really, really amazing large language models now, and video generation and so on, based on massive and massive amounts of information. So that's the second wave of AI. The third wave of AI, according to DARPA, is really cognitive AI, where your focus is on how does cognition work? How can you have adaptive systems that can learn by themselves, can learn in real time? And so the second way to look at it is, if you draw the comparison, if you go back to first principles and you say, well, how does our brain work? How does our mind work? Our brain uses 20 watts, not 20 gigawatts. It doesn't need a nuclear power station, for it to learn what it knows. And a child can learn with maybe 2 million words, not 20 trillion. And so it's really, when you go back to first principles, you realize there's something very, very fundamentally wrong, that you need to first collect 20 trillion pieces of information, number crunch them for weeks on end, hundreds of millions of dollars worth, to then have a model. And that model is read only. It's fixed. It's completely fixed. It cannot learn. It cannot adapt. It cannot, it cannot update. The core model can't be updated. And, anybody who disputes that, I actually co-author of a white paper where we systematically reviewed over 200 papers, recent papers, research papers, where people tried to update the core model in real time. And nobody can do that. There are technical reasons why it really can't be done. And a simple proof is if the model could be updated, they wouldn't be throwing it away every 6 months and spending another $500 million building a new model. If you could just improve the model and update it, that's clearly what companies would do instead of throwing it away and spending hundreds of millions or billions of dollars building new models. So the big data approach, one of the biggest limitations is that it cannot learn in real time, and that's not intelligent. I mean, if you're talking to somebody, having a conversation with somebody, you are learning, you are updating your model, so to speak. The other person is learning, updating their model. The conversation we're having, and that's what intelligence requires: is to be able to adapt to changing circumstances, and not just sort of at a surface level where you're just recording a conversation and can sort of in a very limited way recall. It's really the implications. When you learn something important, something profound, it really can change your worldview. I mean, let me use a practical example here, just to illustrate. Imagine you're a researcher, and you've been doing work in a particular area, and you just come across the fact that some key research paper that you've been relying on has been recalled because I found a major flaw in it. Your model changes completely, all the implications through. But even in sort of mundane things like that, if you imagine having a robot in your house, and you're trying to use a robot that's been pre-trained on how to operate, in the kitchen or do your laundry or whatever. Let's even say it could do that, which we're a long way away from that, but let's even say it can do that. But now you have guests coming over with a child or so. You need to now understand how everything changes and how you need to interact with them. Maybe they're allergic to the dog or the cat or something. They're going to take over the master bedroom or something. So being able to learn and adapt to changing circumstances, just an inherent part of something we would expect from an intelligent entity, and large language models simply cannot do that. So that's kind of like chalk and cheese. The 20 trillion pieces and 20 gigawatts, and no ability to learn, an opaque system that hallucinates. And then on the other hand, with cognitive AI, you're much closer to 20 watts, a few million words to learn language and reasoning, and you don't have the hallucination and the black box. So very, very different approach.
What's different in the actual building of the core technologies for cognitive versus deep learning?
Right. So deep learning, as we've just said, it's basically you collect all of your data up front, the 20 trillion or whatever, huge amounts of data. And then you number crunch it millions of times, basically. The algorithms, backpropagation algorithms, basically keep going through the data until it's created a model that sort of roughly corresponds to the data that you've input, to give the structure of the input data, the hierarchies. And you can have quite phenomenal results, as we see with large language models. When you have this, it's sort of quite counterintuitive because we don't work with 20 trillion pieces of information. We've never come, in our whole lifetime, we've come across maybe 1/1,000,000th of that. So what you can actually achieve with that is quite phenomenal in terms of summarization and all the good things that we know that large language models can do. But that's it. And then the model is basically frozen in time. It's a read-only model. And then to do useful things, what people then do, they add external databases to it. They write a lot of specialized prompts. They might do some fine-tuning on the output layer to basically say, no, don't say that. That's naughty, and things like that. So there's a lot of human engineering to kind of around the edges to try and actually make these things useful. And then, of course, as circumstances change, your business rules change, your product changes, your demographic changes, or your use case changes, you then have humans going in and again tweaking the system, changing the way the RAG works, changing the prompts, and so on. So that's basically how large language models work. And agentic systems, which is sort of the latest craze, are really no different. It's just that you have specialized agents that are small language models, so to speak, in some kind of a workflow. But they still, have the problems of inherent hallucinations, and they read only at the core. So that is really the whole, second wave statistical big data approach. With cognitive AI, and then number of different approaches, and really there's very little activity happening in the world around cognitive AI. And it's an accident of history in a way. It's that large language models have been so successful and have attracted so much money that sort of just generates this tremendous momentum, and it sucks all of the oxygen out of the air. In fact, I have a personal example where one of our staff members who really believed in cognitive AI wanted to do a PhD. He couldn't find a sponsor for cognitive AI, so he ended up doing his PhD in machine learning, deep learning, and he's now lost to the cause. It's the only game in town. You want to earn the big bucks. It's basically that. So very few companies are actually working on cognitive AI. As I say, really primarily as a kind of accident of history. I can talk about our own approach. So our approach is that instead of collecting, all this data up front, our core technology is a super high performance vector knowledge graph. So it's a knowledge graph that encodes and represents all of the knowledge and skills that the system acquires. But it's a vector graph database, which means it inherently has fuzzy matching. So it has the qualities of a neural network, while at the same time not being opaque. So it's not a black box. So it doesn't suffer the brittleness of traditional logic-based systems because it's vector-based. But yet you can use logic operations at a higher level on the same knowledge representation. So we have that core knowledge graph that's the backbone of our system. And then the cognitive algorithms, the learning algorithms, these are real-time incremental algorithms, are custom designed for our system, and they are designed to work synergistically with each other and to work to be embedded in this knowledge graph. So then once we have as we use this basic system, we then teach it like a child from the ground up, language understanding, reasoning, and so on, and we build up the knowledge graph, in an incremental way. So very, very different approach. And in ours, it's not the quantity of data that matters, but the quality of data, the quality of the curriculum, the teacher. And of course, we control that. And then over time, the system becomes more and more autonomous, like a child. It can hit the books, can start reading bedtime stories by itself, and then it can read Wikipedia, and then it can eventually read research papers by itself.
My understanding is when you're building AI models, and this could be generative or I guess as well as AGI, generalized, there is a training phase, then there is putting it into a usable format, and then the continuous learning. How do you put together this core knowledge graph? Who decides, like, I'm thinking like in generative AI, we have OpenAI, we have Anthropic, we have like multiple different core, I guess, models. Is AGI going to be the same? I can build my own AGI model and you can build your own?
Yeah, that's a very good question. I do want to just pick on one thing you said, just that the audience isn't confused about that. Large language models cannot learn on an ongoing basis. They can update the external database and so on, but the core model itself cannot change. And that's a really important distinction, key one. So we are still developing our AGI solution and going up the learning curve in terms of, 4-year-old, 5-year-old, 6-year-old, to get to full adult level, sort of self-learning ability. But the large language models are really very much the same. They all use very similar data. I mean, Grok has access to Twitter where others don't have access to Twitter, but with 20 trillion pieces of information from out there from the internet and so on, there's a lot of commonality on these foundational models that everybody is building. Now, with AGI, you don't need to keep training new models. You basically have a model, or maybe multiple companies will have their own model. And I actually hesitate calling it a model because then people think it works the same way. But you have an AGI that has been trained with a curriculum, with teachers, with, again, like a child, let's say up to a college graduate level with general knowledge. You know about mathematics, you know about history, you know about languages and so on. So a smart college graduate. So that would be sort of akin to the foundational model. But the huge difference is the system can then learn by itself. You don't need to collect a bunch of data and do a whole lot of engineering. It literally is like you or I would go into, for example, a call center. If we were doing customer support, we would just go into the call center, we'd read the manuals, listen to some calls, ask the supervisor some questions, and then we could start on the job. And when something is above our pay grade, something we can't handle it, we would know it, and we'd hand over the call to somebody else, and we would improve on the job as we go along. In the same way, that very same model, that very same college graduate AGI that you have, it could go into a law firm, could go into an accounting firm, could go in, could learn programming, or do cancer research. So that model is then, you have to look at it cognitively the same way as a human, as a smart human, smart motivated human that can basically just learn, by themselves and on the job, which large language models cannot do at all.
So would an AGI have the other human traits, like getting depressed, becoming happy?
That's a very interesting question. There's actually a very good book called Affective Computing by Rosalind Picard from MIT. And she actually analyzes different kinds of emotions that humans have. And to simplify it, you could really divide emotions into two categories. You can say there are what I would call cognitive emotions. So emotions necessary for cognition. So that would be things like surprise, boredom, certainty, things like that. Again, large language models have the problem they don't know what they don't know, and they'll carry on with full confidence about making up complete BS. So you do need that kind of awareness of yourself. How certain are you? Are you confused? Are you bored, about something? So those are cognitive emotions. Then the other emotions that humans have are really survival and reproduction emotions, sort of call them reptile brain, shared with animal heritage. And those are necessary, obviously, for humans to reproduce and to survive. Otherwise, we wouldn't be having this conversation here, the selfish gene. But there's absolutely no reason for an AGI to have those emotions, anger, love, hatred, and
jealousy and
jealousy. There's no reason for them to have them. Now, to be sure, they will recognize them in humans, but they will not sort of experience them to change their behavior like it does for us. They won't have an ego, for example. So if you have a AGI cancer researcher, or make 1 million copies of them, they will share information without the ego getting in the way. And no, they will have cognitive emotions, but not the sort of survival reptile brain type emotions that also cause a lot of problems for us.
When you say you want to get to a point of a 25-year-old adult reasoning, you're not talking about the emotional side of it. You're
No,
talking about the
yeah.
reasoning part of it.
I mean, if I have to think of how many years of my life I spent pursuing romantic things that I could have spent building AGI, but not that I feel they're wasted, but that's why we're humans. There's no reason to build that in. I mean, nobody building these systems is building that in. Now, with large language models, of course, a lot of these sentiments are picked up from the 20 trillion pieces of garbage, good, bad, and ugly stuff that's out there. So obviously, a lot of the human traits that maybe, well, good and bad, are embodied in these large language models simply because of the language statistical learning. But in an AGI, you won't have that. You'll have the understanding of it. I mean, you'll be able to read, it'll be able to read novels that explore human psychology and love and war and all that, and it'll understand it cognitively, but it won't be driven by those kinds of emotions.
So you can control the training side of it. But once an AGI becomes live, if there is such a moment, then it'll start learning by itself. Do you still have guardrails around emotions for it?
Well, we don't learn emotions as such. In fact, the opposite, we learn to control our emotions. Emotions are there inherently. As I say, they really sort of think of them as a reptile brain. They come from our animal heritage. So it's we learn to control our emotions. It's not that we learn to acquire them. I mean, obviously, some men have to learn to express their emotions, but it's not that the emotions aren't there. So an AGI, there's no reason at all to believe that it will acquire these emotions of love and hatred and a need to reproduce. There's just no reason to believe that. It doesn't depend on the training as such. The training certainly would help on how effective a system is, and there you could use the analogy of education in children. If you were raised to think by yourself, to think logically, if you had a good solid education, sort of a Socratic type education that makes you think by yourself, and sort of that you can have your own thoughtful ideas rather than just repeating what other people say or go with fashions. So if you have that kind of good education that's solid in being able to do your own reasoning, your own research, and so on, that'll be a more effective AGI than one that may have very sort of sloppy training, a bad curriculum. But because inherently an AGI also is very, very good at rational thinking, I mean, that's sort of the inherent part of the computer logic, it will actually be able to overcome even sort of limitations of training, because say, well, what I learned there doesn't make any sense. Like smart humans also do.
Right, right.
We're raised with certain beliefs, and you come to a point and you say, well, that doesn't actually make any sense, just because everybody else in my community believes that, it doesn't make it right or true.
We are hearing from people at very high levels making claims that we have achieved AGI in certain areas. For example, I heard in self-driving, some people saying that we've already achieved AGI, or language models right now are moving and will achieve AGI.
For me, obviously, it's a little annoying having coined the term, together with two others, that it's kind of abused in this way. But of course, you don't own a term. Once you coin it, it gets out there, and people do with it what they want. But still, I think it is a pity that people fall for that. I mean, I'll quote one specific thing. Sam Altman said a few months ago, I think it was, we'll have AGI soon, and it's not going to be a big deal. So either he's ignorant or he's lying, or both. I'll put it as strongly as that. Because if we have AGI, it'll be a big deal. There's just, you can't say we'll have AGI soon, it's not going to be a big deal.
Or he has a different definition of AGI.
Right, but they water it down to when it becomes meaningless. They do that obviously to raise money and, to say, hey, this is not 10 years away. You know, give us money now, then we can come up with AGI, but absolutely not. It's abusing the term for, you know, fundraising or marketing purposes, or out of ignorance. Your question about self-driving, I actually own a Tesla and, you know, use the full self-driving, so-called full self-driving, and it's quite phenomenal. In fact, it has improved a lot over the last year, and one can do many trips, you know, really unsupervised, and it's quite impressive. But it's not AGI. I mean, AGI, artificial general intelligence. You know, my Tesla will not learn how to play chess or, you know, how to do container optimization. But even more mundanely, even within its domain, if you say, well, it's an expert in its own domain, it doesn't have true intelligence, or at least not the kind of intelligence that we are seeking. It's not adaptive. And, you know, to use an example there, if if you move into a new neighborhood, or somebody else moves into your neighborhood, and, you know, you drive around the corner and there's a blind driveway, and you realize now that the people who are living there have kids that run down the driveway, or somebody reverses out of the driveway, or the dog starts running out of the driveway. Now, that only has to happen to you once, and you say, okay, right, I need to be careful. You've now learned how to negotiate that particular corner. And, you know, there are thousands of things like that happen. Now, Tesla's you know, a deep learning, machine learning system like that simply cannot do that. The individual copy of it is a read-only copy. It cannot learn. It cannot adapt. Now, you know, Elon is a smart guy. His company engineers are very smart. Maybe they'll put an extra layer on the outside at some point where, you know, you can sort of customize your own driving situation, or local situations. It's certainly not impossible, but it's human engineered then for that particular extra capability. You know, it can never learn. So to call any kind of specialized system AGI just doesn't make any sense. You know, the whole idea is artificial general intelligence, that you have this AGI that can learn really any cognitive task that a human can learn, and of course many others beyond that. And going back to anybody in deep learning, she was interesting. Just at South by Southwest, I was on a panel. There were about 400 people in the room, and after the panel started explaining, you know, what the limitations of large language models, that they are read-only, and the hallucinations, and that they're really inherent limitations. And after 20 minutes or so discussing that, the moderator actually asked the audience, who believes that large language models can get to AGI? Not a single person put up their hands. Now, of course, there might have been a bit of peer pressure, but still, the sentiment in the room was, you can't do it. And I'll actually also quote Jan LeCun, the chief scientist at Meta, and he put it very, very forcefully. He said, and I quote, large language models are an off-ramp to AGI, a distraction, a dead end. So that's how forcefully he puts it. And I believe that. And you really just, there's a kind of one very simple argument. If you agree that true intelligence, human level intelligence, the kind of intelligence we're looking for, requires real-time incremental learning, you know, the ability to update your core model, to think through the implications of something. If you believe that that's an essential part of intelligence, then we also know that large language models cannot do that. I mean, GPT, pre-trained, you know, generative, makes up stuff, P, pre-trained, T, transformer. And transformer technology inherently requires this backpropagation, meaning you have to have all of the information up front, you number crunch it for hundreds of millions of dollars worth. So, you know, GPT basically very much tells you what those limitations are. So so anybody working on deep learning, machine learning, big data approaches cannot claim to be on the road to AGI. Not possible.
I don't think what you're saying means that generative AI is useless and should not be used, correct? You're just mentioning that it is not the road to AGI.
Correct. And, I mean, many famous people have said AGI will be bigger than electricity when it happens. I mean, it's a whole different ball game. But absolutely, deep learning, machine learning has been incredibly useful and valuable. I mean, when you look at deep learning, AlphaFold, for example, how that's helping in biology and medical research and material research even. Large language models that we use every day, I mean, again, the room of people, 400 people, who uses LLMs every day. Every hand went up, I mean, we all use them. But they are tools for us. The human needs to be in the loop to decide when the tool is useful, when the tool is accurate, and how you need to tweak the tool, how you need to use the tool, which tool to use for what job. For example, I sometimes use large language models, and I say sometimes, to help in my programming. I still program every day. I basically need to decide how much I want to use it. I invest a little bit of time. If it can give me the answer and the answer is correct, then great. It saved me some time. But if I get to a point where I realize that it didn't give me the right answer, then I just need to discard it, abandon it, because I can end up spending more time debugging it or struggling with prompts or whatever than just doing it, by myself. So it's a tool that we could use, a very, very powerful tool for idea generation, summarization, obviously translation, speech recognition. I mean, image recognition. The self-driving wouldn't be possible without deep learning. So it's incredibly valuable technology, and there's still a lot of money to be made, but not the level of money that the valuations suggest. And we're starting to see that the CEO of Microsoft just, I think, a week ago, 1 or 2 weeks ago, said they are scaling back on their investments of data centers because they don't see the commercial return. Because what enterprise companies are finding is to use these large language models, to actually use them in a way that they can be customer facing, or they can be relied on internally. They need to do an enormous amount of human engineering to basically, set up the databases, to fine tune the model, to put guardrails around it, to do all the prompting, and that actually ends up being very expensive. And then you still have the potential of hallucinations. You still have that thing always, hanging over your head. And as soon as anything changes, your business rules change, your customers change, your demographic change, your product change, then humans have to go in again and tweak the system and rebuild it and so on. So to actually get commercial value out of it is non-trivial. I think the companies that are best off there is if they have specialized expertise in an area, like a particular area of law or real estate or whatever, and they can train a model, for that particular thing, plus using their expertise and their knowledge of the particular industry to implement this AI technology. But it's not a slam dunk, and as we know, there's no moat, basically, or very little moat, and prices are falling. So how do you make money out of this unless you're NVIDIA?
There's definitely enormous industry built around generative AI. So much investment going in, and definitely a lot of value as we see manual work being automated by these generative agents. How could an AGI work in a retail environment?
We've been commercializing customer support for many years in our commercial companies. One of our investors and a good friend actually runs a large supplement company. Naturally, we said, well, let's put our technology into your company, And then I went in to analyze it, and very quickly I realized that it didn't make sense for us to automate that, because this particular company is very high value, very value added. So they actually wanted their customers to call them on the phone, because more often than not, they would ask for some advice. I've got this condition here, not medical advice, but kind of getting close to that. The representative could say, things like, you know, my brother has been using this. You know, he had the same condition here. You know, or my niece, or whatever. Or I used to suffer from that, and it really helped me here. That you don't want an AI to make up stuff like that. At least I don't, and you know, the owner of the company didn't want. So I said, no, no, this is not the right application. And of course, the more they talk, you know, they upsell and they, you know, create that good customer relationship that they start relying on each other. For, so you know, that kind of job, unless people just say, well, I'll deal with a company where I don't get that personal interaction, but I can get them a lot cheaper, and then I can just deal with an AI. You know, an AI can help me with advice and so on. Or some people, there's actually the sort of flip side of the coin, where often in medical conditions people don't want to talk to a human, and they're more comfortable talking to a computer, telling them their embarrassing conditions or whatever. So they both have these kind of use cases, but that's really the only criterion to say, is there a particular value in talking to a genuine human, or the cognitive task of doing market research, you know, and finding out or giving people information? An AGI will be able to learn any of those, and quite frankly, do a better job than most humans. I mean, most call center operators are not very good. You know, they don't love their job.
That on top of not being probably product experts. When you look at a shopping experience, all of us are consumers, always thinking about, I need this, I want that. We start from a question or a desire,
Mhm.
and then we need to capture information. Now,
Right.
what are the options?
Mhm.
That part of what are the options is done a lot better with AI.
An AGI will be tireless in doing that. You know, I mean, when we do it, we click on maybe five, or with a push on 10 different stories, and then kind of, oh, okay, this looks good enough, or no, I'm not going to take it. So an AGI will actually be much better at that kind of uh, what human experience has actually been, you know, and to distill this down to a more reliable version of it. I sense there's still kind of a feeling that AGI is just a little bit better than large language models, and really it isn't. You know, it's like chalk and cheese. It's really very, very different. Large language models and customer support are very, very limited. Basically, you know, you have to have a lot of data. You have to have a script. That's why only large companies can use them. Small companies can't, because they, you know, you have the owner or a small group of people who know all the different aspects of the business. Changes every day. You know, they have new products. You can't train a large language model on that. But an AGI could do that exactly what a human can do, and in fact better, because you know it has photographic memory. It would remember the 1,000 people individually that it's spoken to in the last month or the last week, which as a human we can't, you know, and could pick up the conversation again and said, oh yes, you called me 2 weeks ago about this, you know, how did this go? You know, did you buy it, or what's your experience, you know, which as a human we can't do. So no, an AGI, because it can learn and has real intelligence, doesn't hallucinate, is a completely different ballgame. And I actually do want to talk, you know, you talked about advertising, that, you know, inherently that everybody's pushed into advertising. And I like to talk a little bit about my philosophy of AGI, and I hope other people would, companies will adopt that as we get to AGI, is I really believe that AGI should be put to the service of helping humanity flourish. I believe one of the important ways in which AGI can really help us is what I call a personal assistant. And the reason I double up on the word personal is there are two meanings of personal that are here relevant. The first one is you own it, it serves your agenda. So it's your personal property, it's your personal assistant that you own, not some mega corporation that, you know, it's not serving their agenda, it's serving your agenda. Like, you know, if you ask Siri about the latest Android, you might not get the best answer, you know, or ask Siri, ask Alexa about specials at Walmart, you know. So and you know, and even OpenAI are talking about introducing, they're desperate to show revenue. They're projecting $46 billion loss still. So they're obviously desperate. So they're starting to talk about injecting advertising into it. That's not what AGI should be about. So the first personal is you own it, it serves your agenda. And the second personal is it stays with you and it learns about you, whatever you want to share with it, your goals, your history, who your what your community is, your friends, and all of that. So in a way, it becomes like an extension of your mind. But on the other hand, it's like a little angel on your shoulder as well that can give you advice, can also do the dirty work for you, like dealing with insurance companies and stuff like that. Really more that it can help you think things through and make better decisions and actually make you a better person. And I believe that needs to be free of advertising completely. And in fact, in our model, we would want to make that available to everybody in the world, free of charge, at a basic level. If you want to use it for business, of course, then there is a charge for whatever that business expertise there is. That's one key application for AGI. The other one is, of course, what we've been talking about is dramatically reducing the cost of goods and services by dramatically reducing the cost of labor. And then the third category I'd like to highlight is the one of research, that I touched on, is where you can have one college graduate AGI, our generic AGI that we have, that teaches itself to become a PhD level cancer researcher. And it's not going to take 7 years to do that, because obviously it can do that 24/7 at a much higher speed than we can do without the distractions of dating. And you now have this AGI that trained itself to be a PhD level cancer researcher. You can now make 1 million copies of that and have 1 million PhD level cancer researchers chipping away at the problem, pursuing different ideas, collaborating without egos getting in the way. Now you apply that to every scientific endeavor, whether it's fusion power, clean power, whether it's nanotechnology, to truly have nanobots that can go into our bodies and clean up the gunk. Whether it's environmental cleanup, the kind of wealth and abundance that we will have through technology, how it improves our lives by conquering diseases, and then having our personal assistant. To me, AGI, absolutely fantastic development for humanity.
So a PPA instead of a PA.
Yes, almost everybody I talk to when I explain about a personal assistant, to say, when can I have one? We're working on it. Help us grow our company, and we'll get there sooner.
Can an AGI learn only in software form, or does it need access to the physical world?
Yeah, that's a very interesting question. And the amount of grounding that it needs on how it needs to interact with the world, it's really not clear. Nobody knows how little interaction with the real world. It needs some interaction with the real world, but how much it needs. So it's somewhere between. Large language models basically only have text input, or voice now, but essentially it's text input output. That's not enough. We already know it needs at least some kind of a visual input at the very least, and that's why you start to see multimodal models. Our own model is in fact one that lives on a computer desktop, or potentially on a phone, on a smartphone. It can see everything that's on the screen, so you could have a video playing on the screen, or whatever's on the screen. It can manipulate the mouse and keyboard, of course, and so you have text and mouse input, output, and video input. That may be enough. We're not 100% sure yet, of what the limitations are of having something that has a sort of indirect access to the real world, because of course you can have a camera pointing directly ahead of you, or like as if it had eyes to the real world. On the other hand, there's of course a lot of development happening in humanoid robots, or robots in generally. I mean, that's actually a pretty hot area right now. Now, they don't have a brain. They don't have this AGI brain. But putting an AGI brain into a robot is, the kind of thing we were talking about earlier. If you have a robot in your house, but it has an AGI brain, then it can cope with, we have these visitors coming on over with their kid, and they're allergic to the dog, and it can learn and adjust in real time to do that. So we know that with robotics, with AGI, we'll be able to improve robotics. Again, it's a research thing. So somewhere in between having something that can live on your desktop or on your phone. I mean, when with her, that was kind of the model.
Right.
It seemed pretty compelling, but also from a sort of scientific point of view. Um, I'll actually spend just a few minutes talking about it. I call it the Helen Hawking model of AGI. And what I mean by that is Helen Keller was a woman who was blind and deaf, and she became incredibly productive, basically writing books and so on. So very, very smart person, but with very, very limited sense acuity. So that's Helen Keller. And then Stephen Hawking, who obviously had extremely limited dexterity and again, very smart. So, there's sort of good evidence that you can have very limited sense acuity and very limited dexterity and still be very smart. So,
Okay.
that's sort of but exactly what is useful. But ultimately, we are going to have robots with, very elaborate sense acuity and dexterity that will also have an AGI brain. So it's just a matter of a time to get through that development phase. But we know we can do a lot with text input and vision input. If you have text and vision, and that probably is enough for almost everything. I mean, you could do scientific research. From a timeline point of view, I believe that if we just have a shift of some resources going into cognitive AI, I believe we can have full AGI within a few years. I mean, something like 3 years, 2-3 years, that we can have that. I don't believe hardware is a limitation. Large language models already showing you, from an inference, the usage point of view, you don't need a massive computer anymore. That can already run on relatively small computers. So yes, it's kind of really fun to imagine how this will pan out. But there's so many variables. Will people still want to go into stores, or will it really be just more that they have devices in their home, holographic displays or something that they can try on different things from the comfort of their home, virtually. I mean, that technology is there. But taking your example, yes, it seems perfectly plausible to me that you'd have your personal assistant, and you'd tell it, yeah, talk to the shop AGI, and the shop AGI might be a robotic figure, that moves around the aisles and can take you to where you want to go, and it can basically now have a conversation with you. Now that would be, it could be a robot on wheels. It wouldn't have to be, that technology already exists. Again, they don't have the intelligence right now, but you could basically have this personalized shopping assistant. I mean, you walk into one of these stores right now to try and find somebody to help you. A mass market, you could have these robots in the store, and as you come in, you'd have this greeter. How can I help you? What would you like? Can I take you to whatever you want to see?
Salespeople could have their own PPA.
I have an earpiece, learn about the customer, and when they ask something, it can kind of they can get the answer straight away.
The consumers really don't care if my agent is generative or if it's AGI. They just care about how does it work? Is it really helpful or not?
Yeah.
Did it help me?
Right, but that's a big question. How helpful are these generative AI? And they typically aren't very. I mean, when I was on the commercial side, or I go to a cocktail party and people ask me what I do, I'll say, we supply automation for call centers. People almost immediately say, I hate these things. I always press 0. That's the common reaction and then I say, well, you should try ours. You'll hate it a lot less, Ours are really very good, So there really aren't many systems out there that are good because they lack intelligence. They really aren't smart enough. And to get them to operate at a level that's pleasant and effective, using LLMs is really, really hard. It requires an enormous amount of training data and tweaking and so on. It's very, very labor intensive to do that. out the box, a large language model, you can't put it customer facing. I mean, we've seen the disasters, where a car dealer with a chatbot, he said to the chatbot, can you sell me this car for $5, or whatever, it's something like that. And the chatbot said, sure. And the person said, is this legally binding? And the chatbot said, yes. You can't trust those systems basically because they do hallucinate. They don't know
Yeah.
what they don't know. They don't know what they're talking about. We humans have this metacognitive. We monitor our talk. There's this higher level thing. It's like, oh, what I just said doesn't make sense, or I'm not sure that I can answer this, or whatever. It's what Daniel Kahneman, the psychologist, called system one and system two. Our system one is a sort of automatic thing. That's more like predicting the next word. I mean, not that it works with us, but it's a pattern. We already know how to answer. Customer asks a question, we kind of already know how to answer it. But then we have the supervisory system too that says, oh, this customer is different, or the situation is different, or maybe I didn't understand the question. I need to ask. Large language models really don't have that at all, and that's why they are limited. Why you see so few of them. A lot of companies are talking about it. In fact, the company last year was bragging about replacing 700 agents. Now, just a few weeks ago, they admitted that this was a mistake and they actually lost a lot of customers and they're hiring back humans again.
I don't know of one good customer service chatbot that I really love. I'm seeing companies using generative chatbot even worse.
Automated systems, by and large, are really bad. And some of the older ones that have been very carefully designed over many years, yes, they follow, the tree, but if you're within that tree requirement, then some of them are good, but they've been very carefully crafted and they're not relying on the large language model to just somehow magically make it happen. It is really, really hard to put together a good large language model based agent. It takes a lot of money and a lot of effort of human labor to get it to a point where it works well. And for many companies and for many applications, it ends up not being worth it. With AGI, anything you'd give a human access to, depending on their level of expertise and their job description and so on, you can give the AGI the same access. Don't need to do anything else. You don't need to try and rebuild the whole world's infrastructure for your large language model to work.
So AGI will still need to have access to all the systems. What systems does my personal assistant need to have access to?
You decide. Different people will have different levels of comfort. I mean, this is again why we call it a personal assistant. You decide. At what point do you want to give it access to your bank account? I mean, there shouldn't be any problem, but a lot of people probably wouldn't trust it immediately. Because maybe it is still sending stuff back to some corporate headquarters, and so you have to clearly the company providing a personal assistant by itself has to build a solid reputation. 1 or 2 million pieces of information you need for cognitive AI, AGI. That is literally 10 million times less. The amount of computational power that you need is also like 1 million times less or 100,000 times less. Many, many orders of magnitude less data and compute. And it's very difficult for people to kind of wrap their heads around it. But our proof of concept is our brain, 20 watts, and children learn with a few million words. So in principle, if you look at it from first principles point of view, there is no reason why we cannot build AGI. And from a practical point of view, we have built a number of prototypes that accomplish many of these things, not yet exactly in the robust enough way and scalable enough way that we need to be. That's why still doing development. But we have many proof of concepts and demos and the commercial experience that we have to demonstrate that this approach can work.
When you have access to processing power, you could probably make up a lot more units when you need less per unit, correct?
Exactly. So what NVIDIA, the data centers they're building out and so on, the number of intelligence, LLM intelligences, if we can call them intelligences, the number of LLMs it can host versus the number of AGIs with cognitive AI can host. It can host many, many more cognitive AIs, for business or something, which will run in a data center. That's exactly right. The investments that are being made in large data centers for large language models are actually largely wasted because there is no moat. They're not magically going to do really, really useful things. I think there's a massive overinvestment right now in companies. It is a dirty little secret. Well, it's not so secret and it's not so little that large language models cannot get you to AGI. But there's still this goal of getting to AGI. It doesn't matter how many billions we put in there. So on the one hand, and the way I often explain it is, if pursuing large language models is like going east, it doesn't matter how far you go east, how fast you go east, how much money you throw at going east, if you really need to be going north. And that's kind of the situation. And people will, at some point, they'll wake up. But at the moment, none of the people who've invested these billions of dollars, VCs and that, are ready to admit to themselves that they're backing the wrong horse, because it's not obvious yet what the right horse is. So at the moment, everybody's still hoping and praying that somehow this will resolve itself, But there's lots of evidence that the current companies are not going to get to AGI, not just from the point of view of large language models. They have the wrong background, the wrong expertise. Their expertise is in big data statistical systems. All the people who run the company, who they hire, they're top experts, that's the way they think. And I can give a very concrete example here. DeepMind has now been around for 10 years. DeepMind was formed with the express purpose of creating AGI. In fact, one of the founders, Shane Legg, who used to work for me in around 2000, he was one of the three people who coined the term, Shane Legg, Ben Goertzel, and myself. He's one of the founders of DeepMind, but he has a very mathematical type of approach, not a cognitive approach to AGI. So DeepMind have had 10 years of virtually unlimited funding, and they are nowhere. They have no path to AGI. They've made no progress towards AGI. They've done magical things with, AlphaGo and AlphaFold, and certainly moved the technology forward. Deep learning technology, absolutely, they've moved that forward. But as far as the goal of creating AGI, no, they are going east. And there's no indication that their mindset of the company and all the experts they hired have a cognitive approach that's anything that's sort of natural for them to pursue. So it really requires, you have a monoculture right now of big data. It's got to be big data, and you have people like Sam Altman driving and say, I don't care if we spend $1 trillion. In fact, he said $7 trillion was his number. We've just scaling. We've just got to scale it, make it bigger, 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 and eventually somehow magically we'll get to AGI.
Do you see the possibility of a hybrid state?
That's what a couple of companies are actually looking at, this, what they call neurosymbolic or hybrid, where they're saying is, can we add a logic-based system, sort of somewhat similar to the system 2, our conscious thought? Can we add the sort of conscious model and somehow glue it together with a large language model? That's one approach. Now, that cannot work. Our system 1 and system 2, the knowledge and skills that we have are all in one common data representation. They're all in our brain in the same way. And we can seamlessly change from one system to the other. We're driving along completely subconscious, and suddenly we see some road sign or something moves on the side of the road, and our system 2 kicks in. Okay, I've got to pay attention now and do that. So you can't just take two systems that each have their own limitations. The brittle systems, or logical systems that have their brittleness, and the large language models that basically cannot adapt and hallucinate, and combine them and hope that the problems will go away. Now, our approach is actually a neurosymbolic approach, but we have a totally integrated way of the system being able to operate in a sort of more neural network basis or to work in a more symbolic basis. So it can dynamically change from one mode operation to the other. So hybrid models, no. Now, where large language models will help with AGI development is that they do have a lot of the world's knowledge in them, embedded in them. So as kind of an oracle, and once you have a system that's smart enough to do good prompting and make sure that it's not going to get a hallucination, but it can cross-check the information, between different dictionaries and different large language models, Wikipedia, and so on. So if one large language model gives it an answer that is wrong, it can validate that across other things. So you can have an AGI that can learn a lot about the world using tools like LLMs and dictionaries and databases and so on. So they will be useful towards AGI in that regard. And we're starting our system. We're starting to use LLMs in a limited way as a source of information.
So that will require the LLMs to continuously be updated then.
No, not at all, because you don't want to wait 6 months or 3 months or whatever. I mean, as a perfect example right now, a day before the election, we didn't know who was going to win. Then day after the election, we knew who won. So when do you start training your large language model and all the implications of what's likely to change? If you start training it the day before the election, well, that's a problem. If you start training it the day after the election, well, you don't know how things are going to play out. I mean, the last 60 days have been pretty chaotic. You really need a system that can learn in real time. So once you have an AGI that has all of this college graduate level knowledge and competence, then it will go directly to the sources, to the different news sources. And again, it'll be tireless in cross-checking different news sources and making sure that you're not getting fake news. But no, the AGI will AGI, and you will have specialists as well. You're not going to have one AGI that tries to know everything about everything. It's not possible. Your own personal assistant, for example, will just know which AGIs to have the best information if you want to know about what's going on in India or what's going on in Great Britain or what's going on about the price of bananas or whatever it might be. And you'll have these expert AGIs that are completely up to date with the information in their field. And that makes a lot more sense than trying to have one massive oracle that's updated with good, bad, and ugly information every couple of months.
So the same process that is happening right now, which is a lot of agent marketplaces, for example, are being put together. And that same model is going to continue in the AGI world. It's just going to be the agents are going to be different.
Yeah, I believe so. Absolutely. You will want experts, and there'll be competition of experts on which ones have the best reputation, specialized in certain areas. But right now, these agents each agent has to be manually crafted and manually maintained, the quality of that and so on. I mean, the whole thing is just extremely difficult to manage.
What's the differentiation between specialized AGI agent doing the same thing? Let's say there are 10 different companies that have their own AGI agents for product pricing.
It's a good question. I mean, there could be many things. First of all, having access to reliable sources is not necessarily democratic. I mean, there are companies that have special access to information that isn't generally available. So that would be one thing. But yeah, the reliability, reputation, cost of these, I think there can be quite a variety of, in what specific area, whether you're wanting very, very narrow expertise or whether you're wanting broader expertise in one agent, sort of more multidisciplinary in a certain sense. The cost, how up to date they are, the quality, reputation. I think all of those still allow for a lot of variety. Now, how many different core AGI engines there'll be around? I'm pretty sure that, I hope our company cracks it, and we we become the leaders in the field. And, I have a lot of confidence that we will be. But I'm also not so naive to believe that this cannot be eventually reverse engineered. Once you show people how to solve a problem, it becomes a lot easier to then figure out slightly different ways of doing it. I do believe there will be a wide variety of different types of AGI agents eventually. It's really hard to predict how that will pan out because, of course, the AGI agents themselves will be employed to improve them.
What kind of investment do you think is needed if we want to see AGI in 2 years?
Mhm.
What kind of investment do we need, or if you want to see it in 10 years?
It's sort of an accident of history that large language models are the only game in town, really. So when we talk to VCs, we talk to AI experts and so on, and we start talking about cognition and a system that really starts with understanding how the human mind works, and that it's going to use 1,000,000 times less training data, 100,000 times less compute. Their eyes glaze over. It's so uncommon that they really can't believe it, and usually they don't have the interest or bandwidth to try and understand. They'd have to unlearn a lot of what they've learned. In that sense, it's a challenge for a company to be operating in cognitive AI right now. And there really are only a handful of viable or semi-viable projects in the world right now. Intel has a research project. It's not aiming uh, to anything that's been going on for quite a long time. That is pretty much cognitive. In fact, they sometimes use our slides to present their approach. There are a couple of other smaller projects that are sort of cognitive AI, but really very, very few. So the amount of money that's going into cognitive AI is sort of really completely negligible. We have a team of 15 people right now. With 15 people, yes, it will probably take us 10 years to get to adult level AGI. Now, our commercial product, of course, already worked at adult level, but we had a lot of human handcrafted rules for language and reasoning and business rules. So, we spent hundreds of thousands of dollars to basically build a system to do this particular job. And that's not AGI, whereas the AGI version of our technology that we're working on has none of these rules. The system has to learn language and reasoning like a child from the ground up. And, we are now working at, 4-year-old, 5-year-old, 6-year-old level of language learning. Now, we have a roadmap, and we've clearly identified another 40 people that we need for different aspects of that. And we believe we can get to high school level within 2 years if we could increase the size of our team. There are companies getting seed capital for $1 billion. No product, no revenue, no plan to anything in particular, but they have the reputation of coming from one of the big companies. So yeah, we're looking for 25 million, and I believe that we can get to not quite the college graduate level, but the high school level within 2 years.
What kind of people would these 50 or 40 be? Are these all software developers or?
No, that's actually interesting. So we're not competing with large language model engineers at all. In fact, half of our staff are what we call AI psychologists. It's a profession I invented. AI psychologists, basically people who have a linguistics, maybe education, cognitive psychology background. So really people who understand language, mind, learning. They come up with the curriculum and the tests and the evaluation of how the system is learning, where it's not learning the way it should be. And then the other half are sort of engineers, but not machine learning engineers. It's sort of conventional, algorithmic engineering. We're going to need some vision experts as well to build out the vision system, and then just some general engineers to help with scaling and integration and things, the sort of more normal engineering tasks.
Thank you so much, Peter. This has been very educational and interesting.
This was fun.